Where are you right now? Not just the country or the city, but the exact little bubble of space you're wrapped in. Maybe it's your bedroom, dim and warm. The blanket a quiet weight over your legs. Maybe you're in the corner of a couch, a mug cooling in your hands, the faint hum of a fridge somewhere in the background. What time is it? In your corner of the world? Are the streets outside busy with late-night voices, or so still that even the air feels like it's waiting for something? Look around you for a second. Everything you see, the lamp, the wall, your hands, is wrapped in color, or at least that's what your brain insists. That book cover is red, the blanket is blue, the light is gold. But is any of that real? Or is your brain painting over reality with something that isn't there at all? If someone asked you what color is, you might say it's just what things look like, the way the world appears. Simple, right? But here's the first crack in that easy answer. Your eyes don't actually see color. Not really. They see a sliver of electromagnetic waves, and your brain, without telling you, translates those invisible numbers into something called green, or violet, or scarlet. And that means every color you've ever loved, every sunset, every shirt, every picture, has been a kind of illusion. A convincing one, yes, but an illusion all the same. So tonight, I want to tuck you into this question. If color isn't truly out there in the world, where does it live? Before we answer it, we need to go back, way back. Most of us don't really think about color. We just use it. We name it, choose it, decorate with it, and never stop to question whether it's anything more complicated than it seems. Ask the average person what color is, and you'll hear something like, it's the way things look. It's the shade of an object. It's what you see with your eyes. It feels obvious. If a strawberry is red, it's red because, well, it is. Red is simply part of the strawberry, like seeds or sweetness. The sky is blue because the sky is blue. You could almost believe that if you plucked the red out of a strawberry or the blue out of the sky, you could put it in a jar. We imagine color as a property of the world, something objects own the way they own weight or shape. And in our daily lives, this assumption works well enough. You can tell your friend to grab the green notebook and trust they'll pick the right one. You can stop your car at a red light without worrying that red might mean something else today. But here's where the cracks begin to show: the slippery nature of color. Think about this. The same leaf can look green in daylight, silver in moonlight, and black in shadow. The same shirt can look navy indoors and almost purple outside. If color is a fixed property of an object, why does it change depending on the light? And it's not just lighting. Sit two people down, show them a pale teal wall, and you might hear blue from one and green from the other. Which is correct? Both? Neither? How can something so real feel so negotiable? We quietly brush these inconsistencies aside. It's just the lighting. It's just your eyes. But the truth hiding under those excuses is unsettling. Maybe color isn't as fixed and physical as we think. The stranger cases. Here's one: the dress. You remember it? The photo that split the internet into two warring camps. Half the people swore it was white and gold. The other half, blue and black. No filters, no edits, just one photograph, one dress, and an entire planet arguing about what they saw. The explanation? Your brain wasn't just passively receiving color. It was actively guessing based on what it thought the lighting should be. Your perception was making bets behind your back. Or consider people with color blindness. For them, certain shades collapse into each other. Red and green may merge into the same muddy tone. purple might look like dark blue. The object doesn't change, but the person's experience of it does, which raises the question, is color in the world, or is it in us? The animal kingdom twist. It gets stranger when you realize we don't all live in the same visual universe, not just between people, but between species. Bees can see ultraviolet patterns painted across flowers, patterns completely invisible to us. Birds can see colors we don't even have names for, because their eyes have more types of color receptors than ours. Meanwhile, many mammals, like dogs, see a narrower slice of the spectrum, living in a more muted world than ours. The same flower, the same sunset, the same ocean wave. Every species sees a completely different version. So which one is real? The subconscious story. For most of us, color feels like the most immediate, self-evident part of seeing. You don't have to think about it. You just know the apple is red, the grass is green, but in reality, there's an entire hidden process happening every time you open your eyes, an invisible chain of physics, biology, and interpretation. Light bounces off a surface. Your eyes pick up certain wavelengths. Your brain decodes those wavelengths into nerve signals. And then, something mysterious happens. Somewhere in that cascade of electrical activity, a color appears in your mind. Not outside, not in the air, but inside you. And that's where the unease creeps in. Because if color is born inside your brain, what's actually out there? Is the world truly painted in red and blue and gold? Or is it more like a black and white outline, waiting for your mind to fill in the blanks? The first big question, these cracks, shifting shades, subjective perception, the fact that other creatures see other colors are not small details, they are clues, and they lead us toward a larger, stranger possibility. Color might not be a property of objects at all. It might be a property of perception, which means that before we can really understand what color is, we need to see how science used to explain it. Back when people believed light, color, and reality were one and the same. Because, as we'll find, the story starts hundreds of years ago with experiments that seem to prove once and for all what color truly was. And for a while, we believed them completely. But as you'll see, we were only looking at the surface. Long before color was a mystery, it was a certainty. People didn't just see it. They believed it was woven into the fabric of the world, stitched into objects the way taste is baked into bread. If a rose was red, it was because redness lived in its petals the way sweetness lives in honey. That was simply the truth. For most of human history, this truth went unchallenged. Philosophers speculated. Plato spoke of colors as divine harmonies. Aristotle believed they arose from the blending of light and dark. But these were ideas painted in broad strokes, not measured with tools. The science of color was still a rumor waiting to be born. And then came the 1600s. A restless man named Isaac Newton sat in a darkened room in Cambridge, a small hole in the shutters, letting in a blade of sunlight. In his hand, a prism, polished glass, shaped to bend light. He expected the beam to distort, to maybe smear into a few vague tints. Instead, it shattered. A rainbow spilled across the wall, so crisp and orderly it looked like a secret code. Red, orange, yellow, green, blue, indigo, violet. Newton realized this wasn't a trick of the prism, it was the light itself. White light, he concluded, wasn't pure at all. It was a mixture of many colors, hidden until something split them apart. The birth of the spectrum. Newton's experiments rewrote the rules. He showed that color didn't come from objects staining light. It came from light itself. Objects weren't generating color. They were selecting it. A leaf looks green. because it reflects green wavelengths and absorbs the rest. A ripe cherry is red because its surface swallows every wavelength except red. Bouncing that one back to your eyes, it was elegant, simple, and for centuries, it was enough. We had a story we could hold. Light contains colors. Objects reflect some of them. Our eyes catch the reflected ones. Mystery solved. Science marched on, filling in details Newton couldn't see. By the 19th century, James Clerk Maxwell and others had mapped out how our eyes use three types of cone cells, each tuned to a different range of wavelengths to reconstruct the entire visible spectrum. This was the trichromatic theory of vision, a clean, mechanical process that could explain almost any shade. It was satisfying. It felt final. You could even reproduce it in a lab, mixing red, green, and blue light to create white, proof that color could be built and unbuilt like a machine. The confidence of the old model. By the late 1800s, the story seemed complete. Color was the brain's interpretation of certain wavelengths of electromagnetic radiation. The electromagnetic spectrum itself stretched far beyond our vision, radio waves on one end, gamma rays on the other, but the narrow slice we could see from about 380 to 700 nanometers was ours, our little kingdom of light. The model was neat, quantifiable, and reassuring. It meant that color had a fixed relationship to physical reality. If you knew the wavelength, you knew the color. End of mystery. Painters, printers, and manufacturers use these principles with industrial precision. Photographers relied on them to capture reality faithfully. Even psychologists and educators adopted the idea that our perception of color could be explained with a ruler and a chart. For a while, no one thought to ask whether this ruler was crooked. The first hairline cracks, but nature has a habit of slipping through the gaps in our explanations. One of the earliest challenges came from a German physiologist named Ewald Hering. In the late 1800s, he noticed something odd. There are colors we never see, combinations our eyes refuse to produce. You can see red, you can see green, but you can't see reddish-green. It's as impossible as a square circle. The same goes for yellowish-blue. Hering proposed the opponent process theory, that our brains interpret color in opposing pairs, red-green, blue-yellow, black-white, making certain mixes impossible to perceive. Suddenly, the neat trichromatic model wasn't the whole story. It was just one layer. Then came the discovery of color constancy, the brain's ability to see the same object as the same color under wildly different lighting conditions. A white shirt still looks white in yellow lamplight or blue twilight, even though the wavelengths hitting your eyes have changed dramatically. The old model said color was the wavelength, but here was proof that your brain was correcting, editing, even overriding what physics delivered. The strange truth Newton never knew. By the early 20th century, science began peering deeper, beyond prisms and cones, into the strange world of photons, atoms, and quantum rules. The simplicity of Newton's rainbow started to look more like the surface of something much stranger. Light wasn't just a wave, it was also a particle. Photons had no color, only energy. The sensation of red or blue existed nowhere but in the mind. This was the first whisper of the thought we wrestle with today. The world doesn't have color in any absolute sense. It has light of varying energies, surfaces with different absorption patterns, and brains, like yours, that translate those into a private experience. The old story hadn't been wrong. It had been incomplete. And as we looked deeper, things got stranger. You open your eyes in the morning, and the world arrives fully formed. Bright walls, green plants, the warm amber of sunlight spilling across the floor. It feels instant, effortless. But the truth is, your brain is putting on a show for you, a private performance. And the colors you see are not the raw data from the world. They are the stage lighting, the painted sets, the special effects your brain adds so the story makes sense. You don't see color, you experience it. The secret middleman. Between your eyes and your mind, there's an unspoken translator. Light enters through your cornea, passes through the lens, lands on the retina at the back of your eye. There, clusters of cone cells react to different bands of wavelengths. Short, blues, medium, greens, and long, reds. These cells don't send blue or red to your brain. They send voltage spikes, electrical murmurs. Your brain takes those murmurs, compares them, and builds a sensation. That sensation is what you call color. It's a little like tasting a fruit smoothie. You can't point to the exact strawberry or mango once it's blended. You just know the flavor exists. Illusions you can't turn off. Because your brain is reconstructing reality, it's also editing it, sometimes without telling you. One famous example is the checker shadow illusion. Imagine a chessboard pattern in shadow, where a square in the shadow looks lighter than it really is. If you isolate it, you find it's the same exact shade as a darker square in the light. But your brain, factoring in the idea of shadow, automatically brightens it. You can't stop it. The correction happens before you arrive in the process. Or the dress. Yes, that dress. Half the world saw blue and black, the other half white and gold. The difference wasn't in the picture, it was in how each brain guessed the lighting conditions. Was it in bright sunlight, making the dress look darker, or in shadow, making it look lighter? Your brain made a call and built the entire experience around it. It's not lying, it's storytelling. Your emotional filter colors aren't just reconstructed by your eyes, they're tinted by your emotions. If you're anxious, the world can feel harsher, more contrast-heavy. If you're relaxed, colors may feel softer, warmer. Studies have found that depressed individuals often perceive the world as more muted, literally seeing less contrast between colors. The brain's chemical state alters how your visual cortex responds to wavelengths. The emotional weather inside you can change the color of the world outside you. You may have felt this without realizing. The grayness of a sad day indoors, the golden glow of nostalgia when looking at old photos. These aren't just metaphors. They're small shifts in your brain's sensory processing. The color that isn't there. Here's where it gets stranger. Your brain can make you see colors that aren't in the light at all. Take the phenomenon of after images. Stare at a bright green square for 30 seconds, then look at a blank white wall. You'll see a magenta shape floating in front of you. That magenta isn't in the wall. It's your brain compensating for overstimulated cone cells, trying to restore balance to your vision. Or the neon color spreading illusion, where a simple outline trick makes you see a ghostly wash of color that doesn't exist in any pixel of the image. These effects show that your brain doesn't just receive reality, it manufactures it, smoothing over gaps, inventing consistency, and sometimes creating something from nothing. Private worlds. If your perception is so constructed, then your experience of color is private in a way few things are. You can call a flower red, and I can agree, but there's no guarantee we're seeing the same inner experience. My red could be your green, and we'd never know. This is called the qualia problem, the mystery of subjective experience. Science can measure the wavelengths, map the neural pathways, but it can't step inside your mind to see what blue looks like to you. Color is one of the clearest examples of this gap between objective data and lived experience, the transition to the smallest world. And if that's unsettling, here's where things begin to tip into the surreal. Because all of this, light, cones, neural decoding, still belongs to the human scale. But what happens when we shrink the stage down to the molecules that absorb light, down to the atoms and electrons moving in their invisible orbits, down to the realm where color is no longer even a concept and the rules of reality stop behaving like anything you've known? As it turns out, the smaller you go, the stranger the colors become. Shrink yourself down. Smaller than dust, smaller than pollen, smaller than the grain of light that slips between your curtains at dawn. Keep going, past the cells, past the twisting DNA, past the protein molecules that fold like origami. Now you're in a place where color doesn't exist, not the way we know it. Here, there are only particles and waves, and even those two words are too certain, because a photon, the carrier of all the light you've ever seen, can be either, or both, or neither. It depends on when you look. Molecules as tiny artists. At the scale of molecules, color is born from a kind of selective appetite. When light hits a molecule, certain photons, those with just the right energy, are absorbed. Their energy excites the molecule's electrons, bumping them into higher energy states. The rest of the photons are ignored, reflected, or scattered away. Those rejected photons, they're the ones that end up in your eye, and your brain interprets their energy as a color. Change the structure of the molecule, twist it slightly, alter an atom, and its appetite changes. A blue pigment can become red, a yellow can fade to brown. In this sense, color is nothing but a molecular preference for which photons to keep and which to reject. The quantum curtain. But if you keep zooming down, past molecules to atoms, past atoms to electrons, you enter quantum territory, and the idea of color gets slippery. Electrons don't orbit a nucleus like little planets. They exist in probability clouds, regions where they're likely to be found. When light interacts with them, it doesn't hit them in the way a ball hits a bat. It changes the entire probability distribution, shifting the electrons' allowed states. In quantum terms, color is a side effect of an electron's jump between energy levels. Each jump releases or absorbs a photon of a specific energy, and that energy corresponds to a wavelength, which your brain later paints as a color. But at this scale, those photons have no color at all. They're simply quanta of energy, nameless and neutral, until a human nervous system gives them one. The illusion of a spectrum. We like to imagine the visible spectrum as a smooth rainbow, red blending into orange, into yellow, and so on. But in quantum reality, it's not a smooth slide. It's a set of discrete steps, like piano keys. Molecules and atoms have specific, allowed transitions, and those are the only notes they can play. This is why the light from each element has a unique signature. Heat sodium, and it glows with a brilliant yellow double line. Excite hydrogen, and you get a set of crisp reds, blues, and violets. These spectral fingerprints are so distinct that astronomers can look at the light from a distant star and tell exactly which elements it contains. That means the crimson of a nebula and the orange of a candle flame are both, at their root, coded messages from electrons, tiny quantum leaps carrying their energy across the universe to you. The stranger rules. And here's where the weirdness deepens. At the quantum level, light doesn't behave like light should. A photon can exist in a superposition, taking multiple paths at once until you measure it. It can become entangled with another photon, so that changing one instantly changes the other, no matter how far apart they are. Even more unsettling, photons don't experience time the way we do. From a photon's point of view, if it had one, the moment it's emitted and the moment it's absorbed happen instantly, no matter the distance. The sunlight that warms your face has, in a sense, never traveled from the sun to you. When you realize this, the idea of color becomes almost absurd. We're assigning labels like green or violet to events that, in the fabric of space-time, may not have even had a duration. Color that shouldn't exist. Some colors you see aren't tied to any single wavelength at all. They're born entirely from your brain's comparisons. Magenta is one example. There's no wavelength for magenta. It exists because your brain compares the signals from red-sensitive and blue-sensitive cones and invents a bridge color to reconcile them. In the quantum world, there is no magenta, only a gap in the spectrum that your brain refuses to leave empty. Other colors emerge from interference, where light waves overlap and either cancel or amplify each other. This is why soap bubbles shimmer with impossible hues. Their thin surfaces bend light just enough to make certain wavelengths vanish and others flare into view. The colors aren't in the bubble. They're in the interference pattern between you and it. The beauty in the breakdown. Standing here at the smallest scales, you see that color is neither fixed nor absolute. It's an emergent property, a handshake between photons, matter, and perception. And yet, even knowing this, there's something poetic about it. Every color you've ever seen is a quantum event scaled up into human terms. The emerald green of a beetle's wing, the deep blue of twilight, the amber of autumn leaves, all of them are whispers from electrons making tiny leaps in invisible space. From here, we could keep going down, to quarks, to quantum fields, but instead, let's turn the other way. Let's zoom out, because if color behaves strangely in the smallest places, what does it do when we look at the largest scale of all? Now let's pull the camera back, past the scale of cells, past the curve of the Earth, past the pale blue dot itself, until you can no longer see where you begin or end. Here, color is no longer about apples and shirts and sunsets. It's about the ancient glow of stars, the fingerprints of galaxies, the slow breathing of the universe itself. Starlight as a color code. Every star in the night sky is a furnace, a constant explosion of nuclear fusion. Deep in their cores, hydrogen atoms are crushed together into helium, releasing photons that ricochet outward through layers of plasma before spilling into space. But not all starlight is the same. A star's color tells its temperature. Red stars are cooler, glowing at around 3000 Kelvin, while blue stars burn hotter than 10,000 Kelvin. This is not color in the everyday sense. It's a spectrum of energy, shaped by atomic physics and stretched across light years. Astronomers don't just look at a star's color. They read it, like a secret letter. Split the light with a spectrograph, and you'll see dark lines crossing the rainbow. Absorption lines, each one a record of the elements in the star's atmosphere. In that sense, color in the cosmos is a form of language, and stars are constantly speaking it. The redshift of the universe. But the biggest color in the universe is change itself. When Edwin Hubble looked at distant galaxies in the 1920s, he noticed their light was shifted toward the red end of the spectrum. The farther away they were, the more their light stretched. This redshift meant the universe was expanding. Space itself was stretching, pulling the wavelengths of light longer as they traveled. In a way, the color of the cosmos carries the memory of its movement. The redness of a galaxy is not just its temperature, it's the record of the universe's own heartbeat. Colors the eye can't see. Most of the colors of the universe are invisible to us. The radio waves from pulsars, the infrared glow of dust clouds, the X-rays from black hole accretion disks. These are all wavelengths beyond our vision. To see them, astronomers build instruments that translate them into false color images, giving us blues and reds and greens where there were none. It's a little like a cosmic translator, letting us glimpse a reality our senses weren't built for. But it also means every NASA image you've ever seen is part art, part science, a visual poem created by converting pure data into something our brains can hold. Nebulas and cosmic paintings. Look at a photograph of the Orion Nebula or the Pillars of Creation. The colors are spectacular. Emerald greens from glowing oxygen, ruby reds from hydrogen gas, sapphire blues from scattered light. These aren't painted by hand. They're the natural result of atoms excited by the ultraviolet light of nearby stars, releasing their energy in specific wavelengths. The universe paints with the same physics that colors your living room wall in the afternoon sun. Only here, the canvas is 100 light years across, the blackness between. And then there's the absence of color, the vast black between stars. But even here, the darkness is not empty. If you could see in microwave light, you'd find a faint glow everywhere, the cosmic microwave background. This is the afterimage of the Big Bang itself, stretched by 13.8 billion years of expansion into a whisper of warmth, a reminder that the whole universe was once blindingly bright. That glow isn't colored in the human sense, but it carries the seeds of all the colors that would follow. Every blue ocean, every green leaf, every orange flame, born from that ancient flash, floating in the middle. When you look at the night sky, you're standing between two infinities, the infinitesimal quantum leaps of electrons and the immeasurable stretches of galaxies. Color exists in both places, but it is never quite the same thing. Here, in the middle scale, the human scale, you get to see both versions at once. The starlight that began its journey before you were born, and the way your brain turns it into something you call golden, crimson, or blue. But if the smallest scales, and the largest both, bend our idea of color, maybe there's an even stranger possibility. What if it's all an invention? What if the universe doesn't have color at all? What if we've been painting it in our heads this whole time? You close your eyes. The world vanishes. Its colors, its edges, its light. Yet you still exist. Somewhere in the darkness, your mind hums quietly. When you open them again, everything rushes back. Shapes, movement, color. But here's the unsettling question. Did you see the world as it is? Or did your brain rebuild it for you? We like to think perception is a mirror, faithfully reflecting what's out there. But more and more, science whispers something different, that it's a construction, a model. And models can be wrong. The dream argument philosophers have wrestled with this for centuries. Descartes asked, "How do you know you're not dreaming right now?" In dreams, you see colors, hear voices, feel textures, all conjured entirely from within your mind. If a dream can be that convincing, what's to say waking life isn't just another layer of the same trick? If that's true, then color isn't a property of the outside world at all. It's just a signal inside a self-contained simulation called you. The simulation hypothesis fast forward to today, and thinkers like Nick Bostrom suggest something similar, but with a digital twist. the simulation hypothesis. If civilizations advance far enough, they might run ancestor simulations, entire virtual universes populated by conscious beings who don't realize they're inside a program. In that case, color could literally be a rendering choice. The way a game designer chooses a palette for a landscape, your reality might be painted in code, optimized not for truth, but for efficiency, aesthetics, or some purpose we can't guess. And here's a strange thought. If that's true, you've never seen red. You've only seen whatever the rendering engine calls red. The actual base reality, if it exists, might not have anything like it at all. Consciousness first models. Some theories go even further and put consciousness first, suggesting that reality itself is a kind of mental phenomenon. In this view, philosophical idealism, color is not a byproduct of matter. Matter is a byproduct of perception. Think of it like this. Color doesn't live in photons or in paint. It lives in the act of being aware. Without a perceiver, blue has no place to exist. It's like a song that only plays when someone listens. Your private universe. If all this sounds abstract, consider your own experience. You can only ever see from one point of view, in one moment at a time. No matter how many other people are in the room, your version of that room is yours alone. Your angle, your lighting, your emotional filter. If someone else's perception is different, there's no way to merge the two into a single, real image. The best we can do is agree on names. That is red, this is green. But we're really just syncing up our private hallucinations. The Fragile Agreement Society runs on the assumption that our hallucinations overlap enough to be useful. That traffic lights, warning signs, fruit ripeness, all the practical uses of color work because our brains paint similarly. But under that agreement is something fragile. We've never actually confirmed that what you see as red isn't what I see as blue. We simply trust the shared language, the shared behaviors. It's possible we're all living in overlapping but fundamentally different worlds. Letting the thought settle. If that makes reality feel slippery, good. Not because we're trying to dissolve it into meaninglessness, but because the slipperiness is the reality. The more you try to pin it down, the more it shifts. And yet, even if none of it's real in the solid external sense, it's still real to you. The red of a sunset, the blue of the ocean, the green of spring leaves, all of it is part of your story. Whether it's physics, code, or pure mind stuff, it's the canvas you live on. So maybe the better question isn't, is it real, but what is it telling me? Because as you'll see, even with all our science and philosophy, there are still places where color and reality refuse to give up their secrets. We like to tell ourselves that the story of color is complete, that we've charted every wavelength, mapped every receptor, decoded every illusion. But if you walk far enough toward the edges of the map, you start to notice the unmarked places, the question marks, the places where science, philosophy, and human experience don't quite align. Here, the neat lines between known and unknown blur. The impossible colors. There are hues we can't see, not because they don't exist, but because our biology won't allow it. Combinations like reddish-green or yellowish-blue are blocked by the way our visual system processes signals. And yet, under the right lab conditions, some researchers claim they can make people glimpse them. Colors outside the familiar wheel, momentary intrusions from a realm our eyes weren't built for. What would a color be like if you had no name for it? Could you even remember it? Or would it slip away the moment you blinked, like a dream you can't hold? The limits of our eyes. We can only see a narrow slice of the electromagnetic spectrum from about 380 to 700 nanometers. Above and below that lie vast realms of invisible colors, the glow of infrared heat, the crackle of ultraviolet, the deadly brightness of gamma rays. These are as real as red or blue, more real in the sense that they can burn your skin or pass through your body, yet they pass through our daily lives unseen. What would the world look like if we could see them all? Would we even recognize it as the same place? Color without light. Then there's a stranger thought. Color without light. Phosphonies, those ghostly patterns and flashes you see when you press on your closed eyes, aren't caused by light at all. They're your visual system, firing in the dark, creating its own palette from pure neural activity. This hints at a bigger question. Is color something the outside world gives us, or something our mind can generate all on its own, independent of photons? The paradox of agreement. Even our agreement on color names is built on shaky ground. Cultures don't always divide the spectrum the same way. Some languages have no separate words for blue and green. Others classify what we call blue into multiple distinct colors, each with its own cultural meaning. If the boundary between colors can shift with language, then how solid can those boundaries really be? The data gaps. Science still hasn't fully mapped how the brain turns electrical impulses into the experience of color. We know the steps leading up to it: photons, cones, neural pathways, but the final leap, where sensation becomes conscious perception, remains opaque. This is the hard problem of consciousness, explaining not just how the brain processes information, but why it feels like something to see red. It's possible we'll never bridge that gap, not because we lack the tools, but because the nature of subjective experience might be beyond measurement. Letting mystery be. There's a temptation to want answers, to believe that with enough data, every mystery will dissolve. But maybe not all of them are meant to. Maybe the unknowns are part of the gift. They remind us that no matter how much we learn, there's always something beyond the next horizon. That the colors of the world are not just labels or wavelengths, but invitations to wonder, to feel, to question. And even if we never solve it all, we still live with it every day. We still wake up under a sky that our brains fill with blue. We still watch leaves turn gold in autumn. We still see, without really knowing what seeing is. And that brings us back down, away from the cosmic, away from the quantum, into something closer, warmer, more personal. Because even if color is an illusion, your body has a private relationship with it, one so close you barely notice it's there. Yet it shapes the rhythm of your days. You live in color without even thinking about it. It's not just in paintings or sunsets, it's in your bloodstream, in your hormones, in the shifting rhythms of your day. Even if every photon in the world went dark, your body would still carry a private dialogue with color, a relationship older than language. Light as a biological switch. Your eyes don't just see color, they measure it. Specialized cells in your retina, separate from the ones you use for vision, are tuned to the color of light in your environment. These cells feed information directly to your brain's master clock, the suprachiasmatic nucleus, which regulates your circadian rhythm. When the light outside is bluish, like the morning sky, your brain takes it as a signal to be alert. When it shifts toward warmer reds and golds at sunset, your body begins to release melatonin, preparing you for rest. You don't consciously notice these shifts, but they quietly steer your moods, your hunger, your body temperature, even the way you think, color, and emotion. It's no accident that we describe moods in colors. We talk about feeling blue, seeing red with anger, feeling green with envy. While these are metaphors, they're rooted in real connections between color and emotional state. Warm colors like red and orange can increase heart rate and create a sense of urgency. Cool colors like blue and green tend to slow the pulse, lowering stress. Even hospital walls are often painted soft greens and blues to promote calm recovery. Color as a kind of silent medicine. And then there's personal history. The shade of your grandmother's scarf, the exact blue of the ocean from your first vacation. These aren't just colors, they're emotional triggers. They can bring back entire worlds in an instant. Skin, blood, and signals. Your body also shows color as a signal. Blushing when you're embarrassed, paling when you're afraid, flushing when you're overheated. These aren't just chemical reactions. They're visible cues to those around you, evolved for communication long before speech. In that sense, your skin is a living canvas, shifting shades to tell stories about what's happening inside you. Color in your food. Your body even judges food by color. Ripeness, freshness, safety. These are often decided before you take a bite. Bright reds and oranges can signal nutrient-rich fruits and vegetables. A sudden blue tint in food, like mold, can trigger avoidance. This isn't just habit, it's ancient biology, honed by millions of years of survival instincts. The invisible influence. Because you're immersed in color constantly, you stop noticing its influence, but remove it, and the absence is startling. People who live for weeks under artificial lighting that never changes, like in polar research stations, can experience mood disturbances, sleep disruptions, and even shifts in appetite. It's not the lack of light alone, it's the lack of color change, the absence of the daily dance between blue mornings and amber evenings. Without that rhythm, the body loses track of time, the quiet companionship. So even if the physics of color is an illusion, your biology doesn't treat it that way. It listens to it. It responds. It builds a quiet partnership with the colors around you, weaving them into your sleep cycles, your energy levels, your emotions. Which leads to one last question before we step into the deep past. If color has always been this intimately tied to our lives, how did we first begin to measure it, to talk about it, to tell stories about it? For that, we have to go back, far back, to when humans were first learning to name the shades of their world. Before we had science, we had stories. Before we had prisms and spectrographs, we had myths and metaphors, woven from the same fabric as our fears and desires. The human relationship with color didn't begin in a lab. It began around a fire. The first colors we named. Early humans lived in a world where color wasn't just beauty, it was survival. The green of edible plants, the red of blood, the dark hues of storm clouds on the horizon, these were signals, warnings, promises. Archaeologists have found chunks of ochre, iron-rich earth pigments, dating back over 300,000 years. Our ancestors ground it into powder, mixed it with fat or water, and painted it on cave walls, on tools, even on themselves. In that reddish-brown hue, they found a way to carry the color of the earth into ceremony and storytelling. For thousands of years, red, black, white, and yellow were the main colors used in art across the world. Blue came late because it's rare in nature, at least in pigment form. Color in ancient myths. Every culture built its own relationship with color. In ancient Egypt, green was the color of life and resurrection. It adorned the god Osiris, lord of the underworld. Red symbolized power and chaos, worn by warriors and painted on amulets for protection. In Hindu traditions, colors were tied to cosmic order, white for purity, yellow for learning, red for passion. In China, colors carried philosophical weight: black for water, red for fire, blue for wood, white for metal, yellow for earth. These weren't arbitrary decorations. They were part of a symbolic system that shaped how people saw the world and their place in it. The first theories. By the time of the Greeks, color began to move from myth toward theory. Aristotle believed all colors came from mixing light and darkness, mediated by air and water. To him, white and black were the parents of all other colors. It wasn't until much later that anyone thought to measure color. The medieval Islamic scholar Ibn al-Haytham studied optics, writing about how light entered the eye, laying foundations for later discoveries. The medieval palette. In the Middle Ages, color was both a practical craft and a spiritual language. Illuminated manuscripts were painted with pigments from minerals, plants, even insects. Lapis lazuli, ground into a deep blue, was more expensive than gold. It had to be mined in Afghanistan and carried across continents. That rarity gave blue a sacred association. In Christian art, the Virgin Mary was often painted in robes of ultramarine, the most precious pigment of all. Here, cost and meaning intertwined. The more expensive the pigment, the higher its symbolic value. The Renaissance shift. By the Renaissance, artists began to study light and color more systematically. They noticed how shadows weren't simply black, but full of subtle hues. They mixed pigments to capture the way light shifted across skin, fabric, and stone. Leonardo da Vinci wrote about aerial perspective, the way distant mountains appear bluer because of the scattering of light in the atmosphere. His notes were as much about optics as they were about art. This blending of observation and creativity set the stage for the scientific revolution. The age of measurement. Then came Newton with his prism, splitting sunlight into its rainbow and proving that white light held all colors. From there, the story accelerated. Goethe proposed a more psychological approach, linking colors to human emotion. James Clerk Maxwell demonstrated the three-color theory of vision. Later, spectroscopy allowed scientists to read the chemical composition of stars by their light. Color had traveled a long road, from sacred symbol to measurable wavelength. But even as we learned to quantify it, we never stopped attaching meaning to it. The continuing story. Today, color sits at the crossroads of art, science, and culture. It's a tool for communication, a driver of fashion and marketing, a variable in mood therapy, a clue in astrophysics. We design worlds with it, real and virtual, and still carry ancient instincts about it in our bones. But after all this effort, after millennia of chasing its nature, what if color, as we imagine it, doesn't even exist? After all the centuries of naming, measuring, and worshipping color, there's a quiet possibility that it was never out there in the first place. What if it was always only in here, inside your mind, woven into the private fabric of perception, the mirage in the mind? Every step in the chain of sight is physical until the very last one. Photons bounce from an object, enter your eyes, trigger cone cells, send electrical impulses down the optic nerve. That's all measurable. But then, the final leap. Somewhere in the folds of your brain, the pattern of those signals becomes red, or blue, or gold. That moment, the birth of the color you see, is not happening in the world. It's happening in the darkness of your skull. The strawberry isn't red in itself. It's reflecting light of around 700 nanometers, and your brain is interpreting that as redness. Change the interpreter, and the color changes. If no brain is there to do the interpreting, does the color exist at all? The philosopher's puzzle. Philosophers call these subjective qualities qualia, the raw, what it's like of an experience. The redness of red, the sweetness of sugar, the sting of cold. You can describe them, but the description never is the experience. No one has ever opened up a brain and found a patch labeled red. It's not in the neurons themselves, it's in the way those neurons fire together in a conscious mind. Without that conscious mind, color is just a pattern of energy, which means the universe, without eyes to see it, is colorless. Color as a relationship. Some scientists now suggest that color is not a property of objects or light. It's a relationship. It's what happens when a certain wavelength of light meets a certain kind of nervous system. Without both, it doesn't exist. A rose in the dark has no red. A blue sky on a planet with no atmosphere has no blue. The world is only painted when there is someone here to see it. The alien palette. Imagine a creature evolved under a dim red sun, with vision tuned to infrared light. Our brightest blue would be invisible to them. Their color experience might be something we can't even imagine. Not just new shades, but entirely new kinds of visual sensation. To them, our rainbow might seem as limited and strange as their spectrum seems to us. The emotional hook. If color is an illusion, it's an illusion we can't live without. It helps us navigate, communicate, find food, choose mates. It deepens art, anchors memories, shapes emotion. Maybe that's the point. Reality doesn't need to be true to be meaningful. It just has to be consistent enough for us to live in. And that brings us here. After this long journey through physics, biology, philosophy, and history, standing at the edge of knowing, with the possibility that color is just a trick of the light and the mind. Whatever it is, we've traveled far together tonight. Where are you now? Not in the grand cosmic sense, not in the microscopic quantum sense, just here, in this exact moment, in your bed maybe, or your favorite chair. The air still, the room dim, the day almost over. Your eyes have carried you through so many worlds tonight, through prisms and pigments, photons and nebulae, ancient myths and impossible theories. You've seen color as a wave, as a particle, as a private dream in the mind. You've seen it bloom in the smallest places and stretch across the largest. You've watched it vanish entirely, only to return as something new. And yet here you are, breathing quietly, surrounded by it again. Look at whatever's closest to you right now. Maybe it's a blanket, a wall, your own hand. Notice the color of it, not in the way you usually do, naming it automatically, but as if you were seeing it for the very first time. Let it sit there in your vision, wordless, just light and mind in a private handshake. It doesn't matter if it's real or not. It's yours. In this moment, it exists for you, and that is enough. Outside somewhere, stars are releasing photons that will travel millions of years before they ever meet an eye. Oceans are scattering sunlight into blues you will never see. Leaves are drinking in light, rejecting the green you take for granted. The universe is still painting, whether or not you're looking. And whatever this thing called reality is, right now, it's you. You, breathing softly, still awake, still dreaming.